This is Kevin Kopchynski, Planetarium and STEM Educator at the Science Museum. In June, we have the Summer Solstice and the first day of summer. And you may have noticed on each calendar each year that it's not the same day, and it gives you an exact time that changes from year to year as well. Why is this? Well, in order to understand that, we need to think about the motion of the sun. And you might be thinking, oh, well, that's easy. The sun starts in the east and goes to the west each day. And that's not the motion we're talking about. We need to look at how the sun appears to move from day to day at the same time of day. So our view is set up for 12 noon. We're going to start in March on the equinox, and we're going to step through day by day. And we'll see the sun appear to change its position. Each day will show us noontime. So let's go ahead and get that started. As it starts out, every time we advance a day, you can see the sun move. It is higher, it is noticeably higher in the sky from day to day as we go through the spring. We're into April now. And we'll just keep on heading in to May, and then we're going to get into June. And as we get into June, it seems to slow down. And we get to a point where it seems to just stop for maybe a moment, but as we keep time going, that it then starts sort of heading back down again. And it is at that moment when it stops its upward motion and hangs for just a moment and then starts its downward motion. That is the moment of the summer solstice, and that's why it happens at a particular time. Solstice comes from a word that means sun still, and it's sort of the day that the sun seems to stand still on this daily journey. If we follow this apparent motion for a full year, we would see the sun trace out a figure 8 shape called the Analemma. Okay, now let's look at why this doesn't happen on the same date each year. Our calendar does not match exactly the apparent motion of the sun. It takes the sun 365 and about 1/4 of a day to come back to the same place among the stars where it was the year before. In this view, it's as if the sky doesn't blank out the stars and we can still see them, and we can see the position of the sun among the stars. And we can see that on the solstice at noon, the sun is almost directly underneath of a dim star. So let's see what happens if we go ahead a year. Now it's 2021, and it looks like the sun almost kind of moved backwards. And in other words, it's because the sun hasn't quite got back to its position just about underneath that dim star. It's going to take another about 1/4 of a day for it to get back underneath of that star. And so the solstice is going to be about 1/4 of a day later next year. Well, that's what happened in one year. Let's go ahead and see. That's 2021. Let's go at 2022, and the sun is now even a little further behind where it was, so to speak, and to 2023. Well, if this continued indefinitely, eventually the solstice wouldn't be in June anymore. The position of the sun would continue to sort of drift against our calendar. So we put in a leap day. And coming up in 2024 is going to be another leap day. And when that happens, we see now on 2024, the sun will end up just about underneath of that dim star again on the solstice. So that system of leap year is keeping our calendar pretty well aligned to the motion of the sun, but not exactly, so the solstice is going to vary a little bit each year. Well, for about a month surrounding the solstice, the days are very long. It doesn't seem to change much, giving us a whole lot of time to go out and enjoy those long days. I hope you can do that soon.